So at this point, we should be feeling pretty comfortable with the Cartesian coordinate plane and doing a lot of things with it and considering points that are on it. So let's consider 2 points. One is at -3, -1. Obviously, it's something that I think all of us can do is plot those points. X is -3, Y is -1. Also the point X is 6, Y is 11. And to facilitate the conversation, I'm going to draw the line that connects those two. So I'm looking at this line segment here, AB. The next question says, find the midpoint of AB. Well, to me, to find the midpoint of something, I like to kind of think of it as an averaging process. So if I look at it, my X values are starting at -3, and they're traveling all the way to +6. So what value is in between those is one of our concerns. Same thing for the change in the Y value at the midpoint, right? Y's are all the way up at 11, and they travel all the way down to -1. So we need to figure out the middle there. To figure out the middle coordinate, it's probably my preferred method is just go ahead and take the -3 and 6. So I'm just adding the coordinates at those endpoints, -3 and +6, and then divide by 2. So when I do that, I get 3/2, which is 1.5. And if I look on the number line, here's 1.5, and what I'm doing is I'm claiming that my midpoint is going to be along this line somewhere. And actually, you can see that the other one is probably right there at 5. Just to verify that, we're going to go ahead and do the same thing. I'm going to take the -1, and I'm going to add to it the value 11. And you can see right here, Y values rather are ranging from -1, and then they hit a high at 11. So I'm just taking the -1 and 11, and when I add those together, I get 10, and half of that is indeed 5. So right along this line. So this is my midpoint, and my midpoint is the point where X is equal to 3/2 and Y is equal to the number 5. Next it says find the equation of the line passing through points A and B. Well, in order to do that, we need to figure out the slope of that line, and the slope is the change in Y over change in X, and I kind of see these values written. I see the green lines and the yellow line. The length of those are the change in X and change in Y. Probably I would prefer to write them here like this is the change in my Y value, and then this is the change in my X values, like that. Now let's go ahead and just do this computationally, right? The Y's, I'm going to go ahead and take 11. That's the Y where I end up, and then I'm going to subtract from that a -1. So that's the change in my Y values, which is 12 units. And then change in X, I'm at 6, and I'm going to subtract from that the -3, and I've got a 9 units. So you can see here I'm going up 12. So from this starting point, I'm going up 12 units. And then after I've gone up 12 units, I'm going to go to the right 9 units. So up 12 over 9. That reduces, both of those have a common factor of 3. And if I divide that common factor of 3 out, I get 4/3. So that is the slope of this line that we're trying to find the equation of. I know its slope, and now I'm going to figure out its y-intercept. I'll start with the general equation of a line in y-intercept form, or slope-intercept form rather. And I'm going to go ahead and use point B because they're both positive values. Y at point B is 11, and that's going to equal 4/3 times X at point B, which is 6, and then I'm adding B to that. 4/3 times 6. 6 divided by 3 is 2, and 2 times 4 is 8. And I'm just talking, you can use any method you want to multiply 4/3 times 6, including, but not limited to, a calculator. And that's B. And if I subtract 8 from both sides, I get that B has to be 3. So I know both the slope, 4/3, and I know the y-intercept, which is 3. So the equation of this line would be y equals 4/3 x plus 3. So there we go. We've got the midpoint, and we've got the equation of the line that goes through AB. Okay, so same 2 points. This time we're asked to find the distance between points A and B. So again, we're trying to figure out the length of that particular segment. And I know a couple things, right? If I start at one point, I can move up. In fact, I'm starting at point A. I can move up a total of, let's see, that would be 12 units. This is 12 units long. And then from there, I can move over to the right a total of 9 units. And basically, I connected those two endpoints to create this perfect right triangle, right? Because the line segment that's 12 units long is parallel to the y-axis, and the line segment that's, 12 units long is parallel to y, the one that's 9 units long is parallel to the x-axis, and the x and y axes are perpendicular to each other. So I have a nice right triangle, and this is a perfect setting for finding the length of a segment we call the hypotenuse using the Pythagorean theorem. The general form of it, of course, is that if you take one of the legs of your right triangle, you square that, and you add to that the other leg squared, you will get the length of the hypotenuse. I'll abbreviate HYP squared. So unfortunately, it's not just a matter of adding the 12 and 9. I've got to add the 12 and the 9, and then once I get that product, I need to take the square root of it in order to get the length of the hypotenuse. So the length of this hypotenuse, which is the length of segment BC, is the square root of 12 squared plus 9 squared. And then we're just down to arithmetic. This is 144 plus 81, which is 225. We are taking the square root. And the square root of 225, we're fortunate, is in an integer today. So this segment is 15 units long. The distance from A to B is 15, so 15 units. And if I was asked what's the perimeter of that triangle, I would add the 12 and the 9 to it, and I would have the perimeter at that point. But whenever we're finding the length of these diagonal segments, we need to deploy the Pythagorean theorem to do so. The last question here says, find the equation of the line that goes through A. So we're talking about this point down here. It's going to go through this point A, and it has to be perpendicular to line AB. Well, we know from the previous slide that the slope of line AB, this one had a slope of 4/3, and anytime we have a slope of a one line, and then we want the line that's perpendicular to it, we know if we rotate through a 90-degree angle on the Cartesian coordinate plane, two things happen. One of them is that the rise and the run will switch places. And not only will they switch places, but the slope would have been, if it was positive, it becomes negative. If it's negative, it becomes positive. We kind of summarize this by saying something goofy like the slope of the line, that they're opposite reciprocals. Now, you can take a look at that, and you can see it here. If I consider this particular point, which is at 0, 3, and I take this line segment and I rotate it through 90 degrees, and I'll go counterclockwise, I was going up 1, 2, 3, 4 units, and I'm going over 1, 2, and then 3. Well, I'm going to take the opposite tack. Now, from this point, I'm going to go up 3 units, 1, 2, 3, and then I'm going to go back 4, 1, 2, 3. Unfortunately, it's off the graph paper there. It's right where my O is, or my LO is in slope. Let me try and go the other way. From here, I can go down 1, 2, 3, and then back 1, 2, 3, 4. That one fit. So what we're looking for, and again, you can see I switched the directions. I switched rather the change in X and the change in Y, and I got this. I get this line segment here. Now I know that the slope of this line that I've just drawn in orange is negative 3/4, and I got that just by taking the opposite reciprocal of this particular slope. The other thing that I know is that it's going through the point -3, -1. That's point A. Now, in order to find the equation of that line, I need to use this piece of information to figure out the parameter that we call our y-intercept, because it's not exactly sure where the y-intercept is. I do know that it's somewhere in between -3 and -4, but we're going to have to find that. So I'm going to go ahead and I'll just write this for reference, and then I'm going to plug in my y value, which is -1. So I'll write -1 equals a slope of -3/4, and then I'm going to multiply that by my x value, which is a -3, and then add b. So I have here -1 is equal to 9 force, positive 9 force plus b. So in order to find b, what I need to do to both sides is subtract the number 9 force. So I can write -1 minus 9 force, and it turns out that's what b is. It's not very gratifying though, so let me do a bit of arithmetic with it. -1 is equivalent to -4 force, and I'm going to subtract from that 9 force. And when I do that, I end up with -13 force. So that's my value of b. b is the same as -13 force. Well, is that where I thought it would be? Yeah, actually it is. If I take 4 and divide it into 13, it goes in 3 times with something left over. What is that? Actually, it's I feel goofy that I'm writing this down, but it goes in 3 times. So 3 times 4 is 12. Oh, with 1/4 left over. So it's actually at 3 1/4, which is about right here, which is reassuring because it's about where we thought it should be. So at this point, we can write the equation of this perpendicular line. I've used up all of my room, so I'll write it, I guess, over here. The equation of this line is y is equal to, my slope was -3 force x, and then I need to, my y-intercept is at -13 force. So that's the equation of the line that is perpendicular to line AB, and it goes through the point -3, -1.